So in this video, I want to talk about the concept of pressure and head, kind of what these two terms mean. To kind of think about it conceptually, think about a swimming pool, right? If you just barely submerge your head below the water of the swimming pool, you can feel that pressure on your ears. But what happens as you go a little deeper, or you dive down head first into the deep end of a pool, the deeper you get, the more pressure you feel on your ears, right? So that concept of the deeper you go or the taller the water level above you is, the greater the pressure that's pushing down on your ears. Well, we can think about that kind of in the same way we think about a water tank, for example, right? So imagine I have some water tank, and we look at that water tank, being on the ground here. The higher our water level rises, or the higher our water level is, the more pressure we're going to read. Say we have a pressure gauge, the more pressure we're going to read down here at the bottom, right? The taller our water level is, the more water above us, the more weight there is pushing down on us. And that weight, along with the force of gravity, really is what adds the pressure that we're going to feel at the bottom of that reservoir. And so in water math now, we introduce this concept of head. And the way we kind of think about head is we think about it as potential energy. So the more water above some point, the more head there's going to be. And the more head, the more potential energy behind that, the more pressure behind that. And there's a very specific calculation for this. So let's just say the height of the water at this point right here is equal to 2.31 feet. Right? That's how high this water level is. 1 foot, 2 foot, we're going a little more than 2 foot, 2.31 feet. Now, for every 2.31 feet of head, my pressure gauge is going to read out as 1 psi, or 1 pound per square inch. Right? So for every 2.31 feet of water above some point, in other words, 2.31 feet of head, that's going to give me 1 psi, or 1 pound per square inch at the bottom here. So now we have to kind of think of this and scale this up. Let's just say now that the water level here, we measure the water level here from here to the bottom where my pressure gauge is reading. Let's just say now it's 4.62 feet. Right? I now have 4.62 feet of head from some reference point, in this case, the bottom of my reservoir, where my pressure gauge is reading. Now with 4.62 feet, I'm going to end up with a PSI not of 1, but of 2, right? Because for every 2.31 feet of head, I end up with 1 pound per square inch of pressure. So let's think of this in terms of not just precisely 2.31 feet, but let's just look at an example here. So let's just say I have a reservoir, and that reservoir has a given height of, let's say, 40 feet. Okay, that's the total height. Now, if my water level is right at 50% of my reservoir height, right, then I know the height of my reservoir here is going to be 20 feet. Now, let's just say I have a pressure gauge down here at the bottom that reads the pressure based on how much water is above it. Right? So in this particular case, there's 20 feet of water standing above that. So in this problem, I want to figure out what is the pressure at the bottom of this reservoir, and we want to figure out what the pressure is in PSI. Now I can do that by basically a unit conversion, right? I know that I have 20 feet of head. I now need to convert that. Right? So what I'm going to do, just like our other unit conversions, I want to figure out what is this conversion factor. Well, I know I need to get rid of my feet of head. I need to get rid of feet. So that has to go on the bottom down here. What am I trying to get to? I'm trying to get to pressure in terms of PSI. Right? So I need to bring in pressure in terms of PSI. Now, given our last example that we looked at, or on your conversion sheet it has it also, I know that for every 2.31 feet of head, I get 1 PSI, 1 pound per square inch. So that in turn cancels out my feet. I multiply across, and this time, seeing that this is in the denominator, I'm going to divide. I'm left with PSI in this case, So I'm going to pull out my handy dandy calculator here. So now I have 20 divided by 2.31, and I see that 20 feet of head, or 20 feet of water above some point, gives me a total pressure of 8.66 PSI. We're going to round to 2 decimal places here. I get 8.65, 8008, so on and so forth. Rounding to 2 decimal places, 8.66 pounds per square inch. So that's the pressure that we would measure at the bottom of this reservoir given 20 feet of water above that point.